All right. Hello, everybody. Welcome to the stream. We are back for another week of programming. Yay! We're gonna pick up right where we left off today with the effect system. So, last Friday we brainstormed how we're going to do this system. We're going to be using a function called standard visit and writing out a bunch of functions based on the effect type to determine exactly what function we are supposed to run. So there's going to be a couple of things we're going to have to do here. So firstly, all of these constructors are going to change a little bit because the constructors used to assume that we had some kind of like hierarchy, right? Well, in theory, I guess we could keep these, but we're gonna have to change the update function and the draw functions because they're inherited functions. And the way we're gonna redo this is every one of these is now going to take let's see here, is now going to take instead static versions of these. So all these functions will become effectively static. And what that means for us is we now need to accept potentially a hidden like argument that determines which object these are referring to. So for example, for the meteor, it's going to convert to have the meteor as its first argument, indicating what object it's referring to. So I could name it, let me just call it effect, like EFF. I think that's very okay. And we would do the same for draw. And then the draw functions would also call effect draw or effect update as well, so that it can call its like parent function. And we're gonna make sure in the loops that we still do like this underscore draw stuff, like everything's going to end up falling into place and essentially mimic the inheritance structure we had before for these effects, where every effect inherited from effect, the base class, but the update functions and the draw functions were overridable. So that's what we're going to do first, is we're essentially going to modify every single update and draw function to now be static. So we can do that pretty easily. In fact, these are the same, so I can go ahead and do like a find and replace on the entire thing. We have to remove the override, but we'll include the static keyword in front of it. And then anything that has the draw function, we would do similarly, where we no longer have const, because const is only for protecting the constants of member variables, so we don't need that anymore. And we definitely don't need virtual, which I didn't realize was in some of these, so that can go away. Hi there, Plasticky. Hello. Welcome. Happy Monday. Alright, we also don't need final. That can go away. I think not all of these had the same things, so that's why it's a little inconsistent here. I don't need it to always show how many were replaced. So yeah, we're just getting rid of the junk that we don't need. Get rid of final here. Rid of virtual here. I predicted that this refactor would probably take about 2 days, so we'll see how that goes. Let me see if there's anything else that's weird. It looks like, oh, some of these only had virtual, but no final. Like, very inconsistent, some of these. Very strange. So it's a little warm. I'm gonna turn on the air real quick. Now that it's summer, it gets really hot. Like, ooh, man. So I believe I've replaced all the update and draw calls correctly with static versions of them. And also, oh, but we still have to include the new parameter, right? So that's gonna be a little more difficult because it's gonna depend on the name of it. So we're gonna actually go through and manually do that. For both draw and update, we have to know what the effect is. So we're gonna include the name of the effect as the parameter in each one, like so. We're just gonna keep going down the list, or up the list. Hopefully this is the final refactor we're gonna have to do with this system, because this is the second time we've had to refactor this in a matter of 2 weeks, so clearly we can hope that it's going to be the correct system we're looking for now. And it will take quite a bit to change all this, but this will be the first step towards moving over. So I guess right now I'll explain what the new system will look like. So first of all, these are going to be static functions. Why are we switching to static functions? Well, we need a way to call these. I guess technically they could be member functions. In theory, they could be member functions because we could also do standard visit with standard bind, I believe. We can take a quick look at that, because what we were checking was, okay, what does standard visit accept, right? Standard visit accepts a list of lambda functions to determine how to override them. So it would look like this, right? So clearly we had different, we were testing like, okay, we can store stuff in a lambda function, and that would work. We could also technically do it as a static function, but maybe we could also do it as a member function, right? Like, let's say, for example, we had class C here with the print me function, right? That was a void function. So why couldn't we just do C print me? We would have to bind it because the first argument would have to be implied this. So I think it would be a reference to a C print, oh, hold on. C print me, comma, and then the object. So the object would be obj. So it looks something like that, which I guess technically would work. So do we necessarily need... Oh, it looks like it's complaining. It does not match the argument list. I guess this doesn't produce a function that we can use. Well, I guess the other way is to just call it directly in a lambda. Like, for example, like, what's stopping us from doing something like this, right? Just passing in the object itself and calling, because we know it's a C, so we can, well, do we know it's a C? Yeah, because we can pass it in like this, right? So we can say ob.printme. Essentially, we would be doing the same thing like that. Yeah, that's essentially the same thing. Then we don't need this necessarily, because it's being passed in anyway. Okay. I mean, do we just write a macro for all these? I guess we would write a macro. Like, if the update function exists, we would call it, but what if it doesn't exist? Are we just manually writing these? I guess that's what we're doing. We're manually writing all of these, and then if they don't exist, we're just deleting them. So we would have to maintain this list ourselves. Which I guess we implied, right? We implied that this was going to happen in the first place. But it's like... all these are getting passed in as arguments for the standard visit function. I wonder if there's a way to auto-generate that. Like, can we? I feel like we should be able to somehow. At least I wish we could. Because it's like a list, right? Like... what's stopping us from just... Yeah, let's take a look at standard visit again. I know I said we're supposed to be doing implementation today, but it's like... if there's another way to do this, then I would like to know. So, standard variant value... oh, those are helper templates. As variant, Standard visit though. Visitor. Variants. So it could accept multiple variants too, which is interesting. Okay. Standard visit. During another variant. Type matching visitor. Like, we looked at this last week, right? It's like, okay. The auto-arg template operator will bind... Oh, wait. Yeah. I'm trying to see how we would populate this right here specifically. Like, what is that, right? Using TS operator instructor. Let me see. Can we just provide a list? What's stopping us from just providing a list, right? I mean, that's essentially what this is. At least it's trying to be, kinda. Like, I guess this is supposed to be... Let me see. So when we called this, we're creating a new struct called a new struct of type overloaded. Overloaded inherits from class TS, but this is like I'm not sure what the expansion, what this means in a template setting. That's what's throwing me off right now. Like, what does that mean? I mean, I guess it's just template shenanigans, but does that mean we can't really automate it? We have to throw these in here ourselves? Like, it makes me wonder. It's like, we're inserting these classes, like, we can assume they are standard function whatever. Like, each one of these is... No, that doesn't make sense. I don't know how to think of that. Let me see if there's an explanation in here real quick. Standard forward. Forwards L values as either L values or R values, depending on T. Okay. I mean, I've seen standard forward before, so... I guess the idea is provide these as values and then send them somewhere else. But where else? I guess visit handles that for us. We just have to send it in like that. Which means if we wanted to, could we construct it using standard forward? It would be like a list, right? This is so weird to read. Okay, maybe I won't worry about it right now. I don't want to get too hung up on this. We'll just do it manually for now. So there's two things we have to handle manually with this new system. One is the typing. All the types, if we add a new effect type, has to get added to another list. And the second is we have to provide an override for it if we need it. So do we necessarily want the... I guess making them static would break things, so I guess we don't need to make them static. That keeps this pretty much intact as it is for the most part. Because then we can still do the inheritance portion of this as well. That's actually really nice. So going back here, this file was me showing like what it might have looked like in the future, but I'm like, okay, well, if we're just gonna stick to that, then we just define them like this and call them appropriately. I guess we don't really have to do much then, which is kind of nice. I do like that. Declaration is incompatible? Wait, it's updates void? That's not right, right? What I change? Did I change lightning bolt by accident? That's lightning bolt emitter, lightning bolt? Wait. Why am I in lightning bolt? Lightning bolt is a bullet, right? We don't care about bullets. That's weird. Oh, I changed this too, I forgot. But yeah. I must have thought lightning bolt was an effect for some reason. Yeah, I see what we're gonna do here. Okay. Let me undo all this. Cool. So yes, we're updating the effect system such that we're not using pointers anymore, and we're deriving the type by doing standard visit now. That's like the biggest change we're going for here with this, is standard visit will determine which function it needs to call, and thus we don't need to rely on the vtable and pointers. We can get rid of that system, and thus we don't have to allocate on the heap, we can allocate on the stack, and then we have a manager to make sure the stuff on the stack gets managed properly, at least in theory. So this standard any is going to change now. We're going to make a new using and just call it the effect list, or effect. Effect name, effect T. I guess effect T would be a good name for it, at least for now. And then we would have standard variant, which is what we've decided we're going to use in the long run. I did find out last week that I kind of misspoken about standard variant, and that it's more like the size of it is determined by like the largest of all your types you put in here, which is kind of nice, so there is that. And then inside of here we would put all of our effect names. So let me duplicate this window. That did not do what I expected. Apparently I have no... Oh, that's not what I wanted either. Okay, apparently I have no key set for duplicate tabs, so we have to look at that eventually. So all of our types here are what we're interested in. So we have Meteor. We'd also include just base effect in here. But yeah, we would just go down the list and include all of these. Pulsating fire, sword slash, foreground effect. And again, this would have to be manually maintained, but that's not really the end of the world. Like, it's not like we're adding effects 24/7. And similarly for monster strategies, we have to maintain a list anyways, so it's like, in some scenario, we would have had to do something very similar, no matter what, if we wanted to use this system going into the future. Now, if I do all this... hopefully all the effects get detected right, because they're all defined below here. So it's like, I hope the compiler's not like, oh, these are not defined yet, go define them. Also, I can do this a little faster. I can just multi-highlight, multi-select highlight, and then copy-paste at once. And then we can just do that, do a little cleaning up there. So, that's what our type's gonna look like now. Pretty big variant. It doesn't really tell us what our size is, yes. Maybe it's just undetermined. Well, now that I'm looking at it, yeah, like some of these are unknown, like they're forward declared or something. So that's interesting. Maybe it's gonna complain in a little bit. Anyway, we have effect T here, so the next thing we have to do is go in here under the effect and just put effect T effect here. So yeah, I think we're going to run into the issue where these are not defined, so it doesn't know how to initialize this. So this might have to be after everything's defined, which is okay. We can move everything. Like effect ref and effect manager rely on the effects existing. So let's move everything down a little bit. Yeah, because if I think about in terms of like a header file, right? Like it needs to know what these are in order to determine its size. So now it has an appropriate size. It's 520 bytes because the max size of between all of these to store any of these objects needs at least 512 bytes total. I like how the name's so large, it goes all the way across. Dang. Okay. So yes. Now, effect T is known, which means everything settles properly. Okay, so that's not too bad. We're gonna have 1,000 of these, which is 528 kilobytes, which is not terrible. So far, so good. We've managed to maintain everything like that so far. So, the next thing we have to do is make it so that all these effects, when they get called, like their update function gets called, they get updated appropriately. So we can go under effect update, I think, Actually, no. This isn't static, right? So we have to go to Adventures in Listoria, and we're gonna go to Update Effects or something? Surely there's like an Update Effects function. Maybe? Hi there, Kraton. Good morning. Or afternoon. Wherever you might be. It's good to see you again. So we're in full effect today, implementing the changes we were brainstorming on Friday today. So here's update effects. This is the function, the game function that actually does everything for us. And you can see right here, we call effect update. So firstly, this is no longer going to be a list of shared pointers. We're basically getting rid of the fact they are heap allocated and making them stack allocated. So no longer will they be shared pointers of effects anymore. Now it'll just be a vector of effect T's, and it won't even be stored in here, honestly. They'll be stored in, I didn't realize there was a to be inserted and an inserted vector. I think that's because we technically can't add things to it while we are running. Although that's not true anymore. If we use a fixed size array, we can add and delete effects easily now. Ooh, that's a nice benefit, right? We can add and delete effects on the fly. We don't have to track anything anymore. That's kind of nice. But I didn't realize we would need multiple effect lists, one for the foreground and one for the background, because they get drawn differently. So one's going to be called the foreground effect list, and the other's going to be called the background effect list. And I guess by default we'll say they can each have 1,000. I don't think we'll need more than that for any effect we create in the game. Yeah. And then for expired. Okay, so this is where it gets interesting, because now we have to search multiple effect lists for this effect. So should the effect itself know which list it's in? I think so. I think that makes the most sense. Like, I guess the effect reference should know if it's foreground or background, specifically. Foreground effect by default. We'll just say it's, I guess by default we'll say it's a false, by default it's a background effect. And then we'll make it a foreground effect if we need to. Look at all these words. all these programming characters, yes. So depending on if it's foreground or not, it determines which list we look up. So we can do this. Standard array ref. Checklist is based on that condition. So based on whether foreground effect is true or not. And if it's true, then we're looking at the foreground effect list. Otherwise, we look at the background effect list. I could also do it another way. So here's an interesting idea. We could just have one list. No, that'd probably be more confusing, wouldn't it? I was gonna say we could just do like one list, but with 2,000 slots. The first half is dedicated to the foreground. The second half is dedicated to the background, but then that just add more complexity and things I'd have to remember in the future. So I don't know about that. Also, these are effect managers lists, and effect data is in the effect manager class. Okay, and then based on that, that's going to be the effect list we look at. Although I think I do want to call it effect list. I think that makes more sense than checklist. So it'd look like this. Why can't we do this? Effect manager is no member effect list. Effect manager. What? I think it's just, yeah, it was just catching up. Do you like Python? Someone told me they didn't like Python and I agreed until I learned it wasn't about snakes. Well, I'm not the biggest fan of Python, but I do recommend Python if you are new to programming, as it's very easy to start getting into. It's a typeless language, well, an optionally typed language, I guess I should say, and it's just very easy to get up and running, so it's a very beginner-friendly language. Okay, so let's see here. And then we have this one, which we have to do the same thing for, based on, again, which list it comes from. We're gonna have to do the same exact thing. Cool. So just like that. Sounds like a plan. Yeah. Okay, so we got a foreground and a background effect list now, so that takes care of our original requirement. We're not going to need these anymore. So these were required before because we couldn't modify the list while we were running the game. It's entirely possible the vector would reallocate in the middle of a run of a frame, which would be dangerous because all references or iterators to it would get ruined, including the initial one in here. So that's why we weren't allowed to do that. So that takes care of that. Okay, so no longer do we need these. So these two are now going to refer straight to Effect Manager. So Effect Manager, we have background effects and foreground effect lists. They are called foreground background effect list, so I will update that name. And then we'll iterate through them, but they no longer contain shared pointers. They now contain effect data. So effect data, we have to provide here and here. Effect data is undefined. Oh, right, it would be effect manager effect data. I feel like effect data should be included as like a default type. So I guess in terms of this header, let's just say using struct effect manager, or not using struct, using effect manager, using namespace effect manager. Although it's not a namespace, so I don't know if that actually works. I just want to make it so that this doesn't require me to type effect manager every time. But maybe that doesn't work either. Like, do I not have... I guess if it's not a namespace, then I don't get to use this, which kind of sucks. Or, okay, I have a better idea. We just say using effect manager equals, or not effect manager, using effect data equals effect manager colon effect data, right? That way, this keyword means this as well. I see a standard library does that sometimes, so that's nice. So now effect data will be defined there. I like that better, actually. Yay, there we go. Same brain. Okay, so now that we have that, effect.update is no longer going to be a thing, because if we just call, well, first of all, it's not going to be a thing anymore, because this just refers to it has an effect ID. Here's the effect itself, which is like, okay, but if we call this, what is this? Oh, this is a variant, excuse me. Since it's a variant, we have to determine its type, but we're going to use the standard visit paradigm now for that. So it's going to look something like this, but I just realized I have to put this in two places. So does that mean that overload struct we created earlier has to get saved now? I think that's what's going to happen. So let me go back real quick to our example from last Friday. So right here, a little more interpreting of what this is this morning. It's apparently a struct, but it contains it contains or passes along arguments. It's like a standard forward in a sense. So I think we can store this, at least in theory. Like, it would look something like this. Because now it's a named struct, and you can pass that named struct into here. And it should mean the same thing. It's just initially we were using it just as a struct directly. In fact, you can go one step further, I think, and just specify it like inline. I think it would look kind of ugly. It would look something like, oh, but it's templated. That's the thing. Like, even if you could do this in theory, you would have to like templated, which I don't think is valid syntax, so I don't know. That'd be a little more confusing, I guess. Anyway, it looks like that works, or at least my understanding of that is correct, in that it's essentially a struct that we provide a bunch of different parameters in this case, standard functions. Like, these are all standard functions, right? And then those standard functions, I guess, have, like, it does something with the constructor operator. It's like, I don't know what the using TS operator is, but all I know is that since this is a template, it's going to probably expand this to be like, okay, each of these is a function stored in here. Like, I can only imagine, right? It would probably be like, it would make a class that would have those 3 functions in its class, and then it would go through them. Like, that's how I imagine it in my head. And that's really the best explanation I can give for that right now. So if we made a struct containing all these things and the template constructs them all, then we can essentially pass it to both of these here and it should work. It's a very, yeah, I've been staring at it for a couple minutes trying to dissect it, and we know what a struct is, and looking up this again, because I need a refresher, it uses like standard forward, which you would use in a template to essentially pass the parameters onto something else, and then that is confusing. Like, template syntax is wild. It's its own language, right? So in here we're going to do that. I think I can just throw it in here. I don't think it cares where I throw it. Oh, it is complaining. Template declaration is not allowed here. Okay, so it's got to be outside. And then we essentially construct our object with everything in it. So I'm thinking more about this. Where would I actually want this? Because I don't think I want it in here. It's kind of a weird place to go if we have to update it with new stuff. Like, I'm imagining, okay, let's say I'm adding a new effect to the game. I'm gonna go to effect.h because that's where all the effects are. I'm gonna go straight to the list of effects, which is gonna be down here. Like, maybe I can put these into its own place. It's entirely possible I could do that. Like, maybe a new file for this. It feels like I want a new file that I can explicitly say I'm going to this whenever I have to make a new effect. I feel like that's the most sensible solution here. It'll be effect.t.h. I think this makes the most sense. And we can say include variant. Yes, variant. And then we have to include all those items, so it's going to include effect. Which I guess means... I don't know if we need to include variant then, if we're just going to include effect t here. So yeah, this header will need effect t. I'm just gonna put it at the top. But effect t needs effect, so that doesn't work, right? They need each other. Oh wait, well... Okay, this only needs it in the sense of this is a using. But I need to know what these are to make the using effect t. So that still doesn't work, does it? I guess that means the effect manager needs to be stored in effect t as well, because it uses that. And effect manager depends on... Oh, I guess it depends on effect data, which is... Oh, okay. It's inside that class. Okay. So it doesn't need anything but effect t, so it can go in here too. So I think that's the only thing we have to change, which means this using can now go in there too. And we can include it. Because nothing else here needs it, so it can be at the bottom, because when I include effect, I want to imply that I also need to include effect t.h. Do I? Oh, this needs effect data too. Okay, so this all goes with it. And then I just realized I don't want to include effect t.h in effect.h because we're gonna have that same problem, right? So this all makes sense? Yeah, I'm just moving them in here. Like, I basically took the end of that file and put it in this file. I guess that means I would be including effect t.h and not effect.h. But I would like it to actually be the other way around. It almost makes me want to rename this file to call it like effect base.h or something. Or effect types. Yeah, if I call this like effect types.h, then this can be effect.h. I kind of like that better. And it shouldn't impact anything because everything still includes effect.h, which would include effect types.h. I think I like that naming scheme more. So let's rename effect.h, wherever that is. Where is it? Oh, header files. So effect.h is now going to be effect types.h. And then effect t.h is now going to be effect.h. I think it's just funny that the one with the types originally was called the effect. And I named this one effect t when it doesn't have the types in it. Anyway, yeah, that works. Okay. So we're good there. It includes the other file and then includes this information, so all the order is correct. And then what I wanted to do was we add that struct. That struct contains the list of all the lambdas. So I almost wonder if we can just define that ourselves. Like, okay, can we further our understanding of that to make it more sensible to us? Like, let's say we can construct this ourselves instead of relying on this, right? Would it look something like this? Let me see. Struct overloaded, right? And let's say we just included, I guess, these? Like, I'm trying to think how... I'm guessing this argument is passed into each of the visitor functions within the struct, and it tries to match that argument that's passed into this. Which is why visit has an args parameter that you can pass multiple arguments to. It probably tries to match it with any function that matches that number of args and meets the type requirements. So if I just made this like a print C function, let's say, I wonder if it's just going to say, okay, can it match this function? Can it match a B print function, like print B? Or can it match an error function, which is just any type? Like, see, I'm wondering if this is the equivalent of what we wrote earlier. And then it would turn into something like a new object called overloaded, created just like so, and passed into here. Okay. I guess not. But it's looking for like a... Well, that wouldn't be right. But it was looking for a visitor object, so I guess the question becomes, what is a visitor object? Maybe if I inherit from it or something? So applies the visitor, and a visitor is what? I guess that's what I'm really interested in. Class visitor. How do I see what this class is? I don't know where else I would be able to find this information. Standard variant visit. Standard variant. Variant. Visitor is just a class that has a bunch of overloaded operator. Overloaded? Okay. Oh, wait a second. So, are you telling me that these should be like constructor objects? Is that what we're talking about here? How would this look? Like, it would look something like this, right? Well, they wouldn't be members, they'd be constructors, but is that what it's supposed to look like? In theory? Oh, wait. That's different, huh? From this? Oh my goodness. Okay. I forgot this is a thing. I As member function. Yeah, okay, so this is called for a member function. Okay, that makes sense. And then so it's like this struct is defining these operators in here, and then they would need to be, I guess, voids or whatever. Right? Okay, so now that resolves. Okay, that's fascinating. So that means the template is generating operators of these based on the in our case we were providing these lambda functions, and it was generating these for us. So that's essentially what we were doing. Okay, that's interesting. Now that makes a lot of sense. I'm literally like, okay, so there is a way to, well, the way to generate them is with the templating, because that's essentially what it's doing. Okay, that's fascinating. So knowing that, I could technically write all these in here just as a struct. Like effect overloads. I think I'd rather go that route rather than having them in someplace else irrelevant, because if I'm going to make a new effect, then I would like it to be in the same file where I can see everything and easily edit everything. Alright. That improved my understanding a lot. Thank you. Okay, so effect overloads. Essentially, any of these effects that have update or draw in them, we're going to add them into here to be called. Now, I might end up writing a little macro for this, because it's going to be kind of annoying to write each time. Because it would be like, I would have to write operator, this, whatever the return type is, bool in this case. Wait. So this is for update. So there needs to be another one for draw. So this is like effect update overloads. Or another way to do it is to include the command in here. So we could include as a second argument, like let's say we're back here and we're doing standard visit. The second argument, like let's say these are the functions, this is the effect itself as the first argument. We could say the second one could be like whether or not it calls the update or the draw function. It could be a string or it can be an enum or whatever. And then we can include both in here, and based on the argument, the second argument, that would determine which one it calls. That's not a bad idea either. That would turn into kind of like a switch state or an if statement. But then again, let me see. Yeah, I can go either way. I like that idea though. So, well, let's just do this first. So it's gonna be something like this. Float, well, the type is, in this case, meteor. Effect, comma, float, no. Well, we're thinking of doing the command here, so whether it's a string view or whatever, if it were to match that, then it would be something like function returning function is, wait, what? Function returning function is not allowed. I don't know what that means. I've never seen that before. But yeah, like essentially we call return, I think it's just IntelliSense being dumb, effect.update here, or effect draw, depending on what the command was. Like it could go either way, is what I'm thinking. But we would need the felapse time here, which we could pass using game engine. Let me see. Yeah, we would need the felapse time here, so that could be passed in as a parameter. That's fine. I don't know if I like the command thing. I think I'm gonna leave it out for now. So float felapse time. There's gonna be a required argument for it. It's gonna look like that. And then, like I said, I think I can just turn this into a macro, because the only thing that changes is the type. So we could turn to something like, oh, we could even take it a step further. Maybe we'll just do it as a template. Wait, no, because then I would have to generate them all. I would have to force them all to generate, so I think a macro makes more sense here. But it'd be like, generate functions for like each type, right? Now just include that in here and make it generate this and the draw function, both. And the draw function would look like this. Like, again, I don't know if I want two separate structs. I think it'll be more clear if they are two separate structs, but keeping them together would also be nice because they are related. So it's like, this is the draw function for Meteor. I'm thinking about it. Which means, again, I would have to have a, like, if I'm going to include them in the same struct, I need something to identify both of the operators. So it'd be something like a command. I guess we'll just call this an effect command. Effect overload command. Which means I'll just call this effect overload. I'll just put update and draw. I think I like this. This looks okay. I'm actually gonna make that enum class. I think that makes the most sense. Wait, that doesn't work, does it? I guess it would just match depending on if this was a pixel or a float. Will I run into any issues with that? Yeah, that's interesting. It would actually figure it out itself, in theory. That's fascinating. It would be a little confusing, but it can auto-deduce it. I just have to, like... Well, I'm not even going to see these two, so... Okay, maybe I'll just go this route. I kind of like this. I kind of have to remember, though, that it's going to auto-deduce, right? Like, just have to be wary of that. Okay, so I kind of like that. That's fun. So these are going to be put into macros. Well, a macro. Generate functions. Provided a type. Gonna generate these two based on T or type. I think we'll be okay with that. Okay. And then we would go ahead and put them for every single one of these guys. To include effect, I guess. Now, not all of these actually have these functions, so some of them will error out, but we would just remove them manually. And some don't even have both, so some I have to actually type out myself, which is also interesting. I don't know why I put a comma. Okay, so like, yeah, I think here would be the first one. Oh, that doesn't give me anything useful. That is also not right. Sword slash... What is all this? Oh, right there. Give me... Okay. Yeah, so this one only has an update. It doesn't have a draw, so in that case, I need to exclude it. Or only include one. How very C of you. Or like just laziness, plus compacting things down, I guess. Generate... But yes, very C-esque. Generate update and generate draw. I guess these two can technically exist by themselves sometimes, so I'm just gonna have one and the other. So like this one would only be generate update because there's only an update override for sword slash. Fade foreground effect only has a draw. Foreground effect only has a draw. Pulsing fire has both. Rock launch only has update. Well, not every, like, I guess the other route I could take is forcing all of these to have just empty draw and update functions, even if they don't have them, and then I could do it that way, but with the current way I have it set up, some of these don't have one or the other. So... But wait, that gets me thinking, like, these do have, like, virtual... These are inherited. So calling, like, these technically have a draw function, it's just the draw function of their inherited class. So does that work? Did I even need to do that? Like, does this compile, I guess is my question. Is this legitimate right now? I guess it is. In theory, if they are all effects, which they are, then all these work. Okay. So maybe we're good. Okay, that's fascinating, yeah, because all these will override. So it's either going to be the base class function or the main or the actual class's function. Yeah, my only issue with these being templates is that this is supposed to be something that gets iterated through. So like the template is not going to be generated for every single one of these unless I actually force them all to be, but then like I might as well just write them out like this. Because I'm like, I don't think writing a for loop will get it to dynamically create every single one, because it doesn't know what's going to come out of this. So it's not going to generate the functions. Which, I don't know what happens after that. I feel like then static analysis takes over and says, like not all functions are compiled or something? I don't know. I think standard variant will just complain, because they'll be like, hey, why don't I have an update function? Why don't I have a draw function? Like, that kind of thing. I think that's what would happen, roughly. I don't know exactly. It's hard to say. Templates get really weird. So, okay. So my guess is, depending on what I put here as the second parameter, in this case, it'll be felapse time, that determines which of these visited functions gets called. And then all I have to do is pass in an object of type effect overloads, which contains all the functions. I think in their theory that works. That's fascinating. So I think that is correct. At least I would think so. Am I just messing this up? Let me see. Const effect data float. Oh, I don't think... Hold on. I don't think this generates what I think it does. Yeah, these need to be effect data, which then turns into the type. Hold on. I have to pass in effect.effect. That's what gives us the type. But that's not all. Let me see. So... I don't know. Does it not know what standard visit is? Is that the issue right now? Because I'm like, I don't know why it's not... Why IntelliSense would be complaining about this. Where does this come from? It comes from variant, which should be existing because this includes effect, which has variant inside of it. Pretty sure. And there's so many. Yeah, no, it definitely knows what an effect data is, so it's from that same place. Sphinx. God. Yeah, I do want to read that book at some point. It's a massive book. But yeah, it sounds like it would be a lot of fun though to explore that. Okay. Well, this doesn't quite give what I'm expecting, so I'm not sure what's wrong. It says the size is 1 byte, which is definitely not right. Why is it 1 byte? It shouldn't be 1 byte. Let me see what... Oh, I guess it is 1 byte. Yeah, these are just functions, right? Yeah. No, that's fine. These are just functions that get generated wherever. I don't know what's wrong with this, but before I did something like this and it worked, so I don't know if... I don't feel like that should matter, right? That's the same thing, in theory. It's still complaining. Is it because I have a second argument here? Is that the issue? No. I must be messing something up. Something's different between here and my example. Because I literally aimed to do the same exact thing, right? So... I don't know. That's weird. I would expect that syntax to work, though. Yeah. And this does compile, right? I guess I never tried compiling it, but it should. Yeah, it compiles. Oh, but abort gets called. Oh, abort gets called because that's on purpose. It just runs the... It generates an A, which I don't have anything for A, because I got rid of... Yeah. I did that on purpose to test the throw. So that, yeah, that should be the throw. Anyway... Yeah, this looks the same. I wonder if IntelliSense just has issues with other stuff. Let me just assume it does for now. So... yeah, we'll come back to this if it's still complaining later. But this is what's gonna look like now. We call our standard visit function using whatever effect is stored here, which will then look for the correct operator overload and call it. And then we have this. So background effects and foreground effects is now background and foreground effect list. These return effect data. Oh, you know what? They're probably not supposed to be const, huh? Let me see. I don't think they want to be const. Because... at least, I don't think the update function is non-const. So either way, I think we're forced to deal with that later. Constness. So, okay. So erase if dead. So we're not actually erasing from the list anymore. But we're effectively marking... do we even have to mark anything as dead? We don't. Although we should probably... to keep the same behavior as before, if an effect has, like, become so quote-unquote dead, we should mark that flag. Was this only used to get rid of it? Was this the only use of that flag? I feel like it was. It was to indicate to our system we had to delete it. I'm pretty sure that's all it's used for. And... okay. There are no references to it, apparently. Hello? Try one more time. Yeah, it just doesn't find anything. I don't think we need this flag anymore. I'm just gonna delete it. Because we don't have to delete from our list anymore. Alright, so this is like inserting effects into the list. So we're gonna be changing this whole system. If a new effect has to be added to the game now, we don't have to wait one game tick. We can insert it directly, or at least try to. Now there's an interesting proposition. If the effect list is full, we could store the items and insert them later. There's an interesting idea. I don't know if I care to do that though. The whole point is to get rid of the heap allocation. So if we end up filling up a list and then we have another list, we need to increase the max size, not do this. So I think that goes away. Although now we have to make it so that when we add effect, it actually adds it to the list. So add effect. Okay. So right now, oh, that's the new add effect, which is already implemented. So where's the old add effect? It was under, oh, I guess it's just gone now. Like, I deleted it. Okay, that's fair. So now we have this new add effect, which is fine. Okay, so far so good. I'm just gonna hit build and let's work our way down the list. We technically still have to implement how we're handling the updating, but we're gonna get a little closer as we go along here. Lifetime. Okay, so this isn't effect manager effect list anymore. It's... okay, yeah, it's based on which list. So add effect, whether or not it's in the back or not, determines which list it goes into. Okay. So let's do a standard array effect data. Yeah, it's just gonna take me a while to get used to the new terms, because we haven't been able to use the system at all yet. Effect list depends on whether or not it's front or back. So if back is true, use the background list. Otherwise, use the foreground list. Effect manager. That didn't work. Background effect list. Otherwise, return the foreground effect list. Okay. That didn't work. Oh, also wants to be a reference, not a copy. Cannot be referenced as a deleted function. What? I don't know what compiler's thinking right now, but that clearly isn't right. So effect list. Alright, so lifetime is undefined. Lifetime is less than 0. This is lifetime of whatever effect we got, so it needs to be like data effect lifetime. Or wait, no, the lifetime is storing the data member now. Yeah. Okay, cool. And then here, what's wrong with this? No instance of constructor matches. What is this? This is returning a new effect ref, which should contain... Apparently the size t and int cannot be deduced. It's supposed to be a... int. Somehow this ended up a size t. Oh, it is a size t. We only go up to 1,000. I can cast that just fine. I don't think that's the issue though, because otherwise it would have worked fine. Did I add something here by accident? Oh, I did. I added a boolean. I don't know if that shouldn't matter. Let me see. Argument types are int, add effect. With t equals /. I don't think the t matters here. Here's a short of example of Sphinx with a variant. Is this? Let me see here. What have we got? Banana. What? Oh my god. Let me just grab this. Wait, this is Imgur. How do I grab this image? I just want this image, please. Goodness. Why you make this so hard? Did that not download it? Try that again. Download. Oh, thank you. That's much better. Struct has print. Standard void. Decal value print. True type print. Visitor. Operator. Const expression has print. Has print. So this... Is this essentially saying it's a... like a boolean kinda? I don't know what that... So like C doesn't have a print function. Type does not support print. God, this is so hard to determine. Oh, I think I kind of see what's going on. This right here is like checking if .print is valid, which is then represented as, I guess, a true type. Like it would be truthy, while this is falsy because by default nothing has print. Trying to wrap my head around how this would turn into something sensible is hard. But yeah, that syntax blows my mind. It's a whole nother language to learn, essentially. Wow. That's insane. Okay, so what is wrong with this? It's basically saying it can't make an effect ref. I guess there's no constructor for it. Do I need a constructor? I was kind of hoping the struct would carry it, but then I guess I'm going to make one? I guess I'll just make one. Don't know if I need to inline it, but I'm just gonna leave it like this for now. And say slot ID and effect ID. Oh god. My goodness, I'm hitting every key but the key I want to. Effect ID, slot ID, and that's there. I was kind of hoping it automatically knew what the constructor was because it's a struct, but I must have like messed it up when I added that third member or something. Potentially. Did I miss something? I don't think I missed anything. I think it's just lagging behind. Oh, semicolon there, maybe. Maybe not. Alright, that looks happier now. So effect ref class is created there. Alright, let's see what other mess we've made so far. Expected expression. Oh. Probably don't need that comma. Okay, well, it started compiling stuff, so... that's cool. Hasn't died yet. Well, okay. It hasn't died yet because everything's finishing up. Standard visit, no matching overload found. So now we're back to this, which doesn't really make sense unless I messed this part up, which I don't think I did. It's like what's different between what I did before and what is going on here? Yeah, it is pretty wicked. I wonder if let's see if it gives any more details in here. Could be either could not deduce template arguments for return. Could not deduce template argument for unnamed symbol. Great. That doesn't really help. Unknown type though. It should be an unknown type, right? In theory? Unless I messed up the macro somehow. Like if I just did this, right? Just in theory. Does it like that? Did I just mess up this class somehow? No. Okay. Like how does it figure out that this struct is something it can use? Maybe it's specifically looking for this effect T thing, but... wait, effect T, hold on. I am passing in effect T, which is the variant. Okay. Which then can be matched to any of these functions, at least in theory, right? Like that makes sense to me. It should be able to be matched to any of these functions. Yeah, I'm not entirely sure why this isn't working. Is it like removing this last argument didn't change anything either, as far as I know. Like if I just had this, so I'll just let me see. Yeah, that doesn't. I don't think that changes anything. In fact, I think it's complaining even more now. Incomplete type. Oh, so it is complaining it's not defined. Is effect.h just not included? Or maybe now there's a syntax error probably. Let me see. Expected a declaration. God. Okay, now we're in macro hell. I don't see anything immediately dumb about this. I'm surprised everything else compiled so far. Okay. So I don't actually see the standard visit complaining now, which is funny. So is it the float? Really? Like that's what I changed, right? I removed the float. Because before I had this. Let me look at the variance values. Oh. I guess they all have to be variants. Can I just put a standard variant float in here? Like, just by itself? Is that really what I have to do? Make it be happy? I feel like it should be able to figure that out though, because you can assign stuff to variants. Just like that, so... yeah, this doesn't exist for whatever reason, but it looks like it should. Is there like another example that might show multiple arguments? I don't really see anything that would demonstrate that. A callable that accepts every possible alternative from every variant in variants. A list of values to pass to the visitor. List of variants to pass to the visitor. List of variants. To me, this would make sense then. I'm just gonna try it and see if that compiles. I feel like IntelliSense is not really helping me at this point. Let's just try that and see if that compiles. Because if it does, then that's useful. We can go with that. If this does work, we'll do a quick commit, even though this doesn't actually run yet, just to save some progress, because this is like setting up the basics, setting up all the foundation for the new effect system. We're gonna have to write a bunch of unit tests to see if the new system works the way we would expect, because there's a lot of unknowns right now. It's like, okay, with the new system, if I add an effect, if I add like say 3 effects and then I delete the second one, will adding a 4th effect put it in the second slot? And then do we properly detect when an effect is dead based on its lifetime? That also has to be determined. And of course then making sure the effects actually run by making sure this visitor function does what it's supposed to. So yeah, it is complaining about it again. It's like when I add it, it doesn't work anymore. Which is kind of annoying. Because I would like it to be that way. That would be nice. I originally assumed it would just be like, okay, here's your arguments passed into whatever the operator is. Member operator. Okay, but is this... like, does this even accept multiple arguments to begin with? Like, I didn't even think about that. Right? Like, is that valid? I don't even know. I don't think I saw that. But it's like, this is supposed to be represent like the operator to a member function? Is that... I guess I don't conceptually know what this means. A comma B, swap them, operator left hand side, right hand side. Oh, so this would be like if you had kind of like a move almost. Like, I'm just trying to think conceptually what this means, because I kind of forgot. It's like a move operator, right? No, a move operator... well, a move constructor is different, but I think this is... let me see if there's another use I can understand this. Struct sum S for each sum. Oh, it's literally like you're invoking the struct itself. It's just literally an operator after a struct name. So yeah, I would imagine that would accept any number of arguments in theory. Okay. So I don't think that would be the issue. Like, I could add this to all of them. It should work, in theory. Let me see if that works. So we just do, like, 4. Right? Like, apparently that doesn't work. Or, I guess I'm not doing it right. Because then we get the same error, right? Yeah. So how does that work? Can I do, like, a list? Like, does it only accept one item, but it could be a list? I think that's right. And that doesn't make sense, right? Could be a vector variance? Yeah, no. Alright, let's maybe look at an example with multiple. Let's see. Maybe like standard visit multiple arguments. Had to pass a second parameter. You've passed a callable to standard visit that accepts 2 arguments. A callable to standard visit that accepts 2 arguments. However, the number of arguments of the callable has to match the number of variants provided. Standard visit CV will only compile if C takes 1 argument. And standard visit CV1v2 will only compile if C takes 2 arguments, and so on. Capturing a shared pointer object in the lambdas so that only 1 argument needs to be passed. Oh. Wait. In the lambdas to here? I guess I'm currently not utilizing lambdas for that, but what would that mean? Like, wait. This is line 824. Oh, wait. Now this one's complaining. Wait, because I put it back, right? Oh, so is this the correct syntax? Oh, maybe it is, and I didn't think about it. Variant int? Oh, it is. Okay, that's cool. Alright, so I did have it right. Okay, cool. It was just complaining about this next line, which I never bothered changing afterward. Okay. Alright, good. I was a little worried. I'm like, I must not be understanding something. Okay, cool. I guess I just kind of missed that detail without thinking about it. Alright, so now we're back here. Populate render lists. So this is supposed to sort all the effects from front to back. Okay, so... would this be a problem? Now, this would be a problem. I feel like instead of doing this, I would want to take like a view. When I'm going through this and we render them in order, I just want to take a view that returns a list of these reordered, which should be fine. That shouldn't be expensive. Okay, so we're gonna go with that now. So we're changing how we render effects a little bit, which is okay. So yeah, here's where we do the filter view, but in this case, we need to also do the sorting at this time, which we should be able to do. I think it's just a views sort. Like, is there a sort view? I'm pretty sure there is. Ranges. Okay, maybe not. So we would have to get the range, but we would be sorting it not in place, which would make it a few, right? I'm a little confused right now. But yeah, it would look... there's definitely no sort for this. It would have to be a range, but I think if I sort it, it'll do it in place. Yeah. So I don't know, that's a little weird. Okay, let me think about this. I guess we could sort them, but if we sort them, then I'm gonna have to like... I'm gonna have to redo the internal IDs when I sort them, which is kind of annoying. I guess I was just trying to avoid that, but I might not have a choice here. So let's say we do sort these. After we sort these, we have to redo... oh no, that's not gonna work, because anything that was using like an effect ref originally was pointing to a very specific slot number, I think. Let me see. Yeah, effect ref contains a slot ID and effect ID. So any effect ref that would get sent out is no longer going to be in sync with the effect that was in any given slot ID. So sorting it doesn't really work. We would have to just create a new list, which I guess isn't terrible, because we're talking about a list of 1,000 items. This isn't like super duper crazy. And then sorting the list that way. It's not terrible by any means. And we could filter out anything that doesn't exist already, so at most we'd be copying 1,000 items. I guess that's not too bad. It could be worse. So now the question becomes, how am I going to store, where am I going to store the sorted list? I guess from the point where we actually need it, instead of this function here. So let's go down here. Populate render lists. Okay, so we do already have these render lists, which is where we could send them based on whether they're upper or lower. So they're already sorted by that, and they're ranges that are... oh, they're views. I guess the first thing I want to do is make temporary versions of them, like auto foreground active effects, and... or maybe active foreground effects and active background effects. And we just want to make a copy of everything that... every effect that is not expired between both, and then go from there. And at this point in time, if we're going to copy them anyways, that's when we would sort them. So it would be like foreground effect list from effect manager, foreground effect list, standard ranges. Alright, hold on. Standard ranges sort, and then get a view that is filtered based on that. I guess it doesn't really matter. Either way works. But we have to copy first, don't we? Copy if. Okay, that kind of does both. A copy if does both. Which is more what we're interested in. Okay. This does exist, right? Typed it right? I'm just seeing red everywhere. So I'm not sure if I'm missing something here. Effect. Foreground. Effect list. It's singular. And then copying an effect data. And we only copy it if it's alive. Which I guess we would check for the condition here. I kind of want to make a function for that. Because effect data doesn't know whether it's alive or not, which is kind of funny. I guess it'll only be if lifetime is less than or equal to 0. So copy if it's greater than or equal to 0, which means it's alive. It's not dead. Is this not a thing? Copy. Oh wait, let's look at algorithms. Yeah, I would think copy if would be a thing. Ranges copy if, C++20. Copy range result. The beginning of the wait, what? The beginning of the destination range. The range of elements to copy. Oh, those are, okay, those are copy. This is copy if. Range result. Oh, we need a place to put it. Okay, I guess I create it first then. And then specify it. So this will be a vector of effect data instances. Okay. I could go as far as making them references. They're not going to move or anything during this time. Do I make them references? I think so. I think that will speed things up a little bit. So we'll reference wrapper it. That way we're not necessarily copying the whole object. Right? And then... Wait, I hope this works. I don't even know if this will work now, if we do that. Because it's like, these are effect data we're copying into here, but can they necessarily be reference wrappers at this point? I don't even know if that would work, or if we would have to do like a for each or something. That might be what we have to do instead. Yeah, it seems like that's going to be the case. It doesn't look like it's taking. And again, IntelliSense is just dying out here. I don't know. But that's my theory, is that it probably doesn't like this. Yeah, no matching call operator found. So let's just do a for each. I think that's better. Standard ranges for each. And we'll go ahead and copy it if it's... And copy only the reference to active foreground effects. So active foreground effects and place back one of these. Do I even need the effect data at this point? I guess I only need the effect. We don't even care about the effect data. Probably. Because I don't need the lifetime. All the relevant data is in here. I'm trying to think if anything else needs the lifetime. I think some effects actually use the lifetime. Ooh. That could be a problem. Like, I feel like there are some effects right now. Even just effect.cpp. Let me go look in there. So this is gonna be interesting. Yeah, right now, an effect doesn't know its lifetime, I don't think. Oh, it does have a lifetime member. Oh no. Does that mean we have to keep them in sync? I almost want to do something like... Well, if effect holds the lifetime, why do we have to hold the lifetime in here? What's the point? There's no point, right? So that seems redundant to me. It's just a convenience, but if we really want to access lifetime like in here, we would just go dot effect dot lifetime, and we would get the same result. So yeah, we just have to go one more member into here to achieve the same effect. Okay, so glad to realize that one. This looks okay. It took it. Yeah, just resolving that so we don't have to actually grab, well, now effect is eff.effect.lifetime. And then, like I said before, wait, what? Hold on. EFF is, yeah, that doesn't exist anymore. So it should be eff.effect.lifetime. And then if it's fine, we actually emplace back the effect itself. We don't really care about this effect data thing, which is only useful for collecting information for an effect ref. No member lifetime. Oh, this is a variant, I forget. Shoot. I almost want to say that we really want to take like a referent, so it's for convenience, because we could write a function that says like, okay, get lifetime from the effect data, and then deduce the deduce the type and then return the lifetime, but it's like they all use the same lifetime member. I almost feel like it should come from the effect, like it's going to be like a float reference, and the ref would refer to the lifetime variable in here, and I would just make a constructor for effect data that accepts a new effect ID and a new effect, and then it would deduce the lifetime from effect. But then to retrieve that, again, this is a variant, so I could pass it in when I create the effect, like, because we call add effect, so at that moment, let me go look at add effect again. There's a lot of moving parts to this, isn't there? Okay, so this is a templated function, so at this point, when we make this at the same time, we can say, okay, effect ref takes whatever this effect's lifetime is. We can just like add it. It would be here or something, because every single one has that member. So that template would work for that. Yeah. I don't really see a problem with that. Other than this is supposed to be data, not effect. Well, that's the original lifetime, which is the same thing. Just we're inserting into data. Okay. So yeah, having this out there would be nice as a convenience feature. But at the same time, making a templated function to grab the lifetime on the fly isn't terrible either. Just not really preferred. Okay. So add an effect ref. Effect data. Hold on. Where's the add effect again? In here? Yeah. Okay, so yeah, an effect ref having, well, no, it wouldn't have 3 properties. That would be under effect data, which is right here. Effect list, return true for which index to insert into. But what, how do we insert the effect? I don't even see that, right? I don't think we add the effect yet. That's funny. Okay. So this isn't even, like, done yet. So this case is... it's dead, so this is the... we return true, drop while, because it's a dead slot, so we return it and take the first one. The index is the slot we're inserting into. We have to do more stuff. Like, we never replaced it in the list. So it's effect list, index, becomes equal to a new effect data class that contains so effect data has an effect ID, which is this, I think? Yeah. So we're doing plus plus right now, but really we need to do int new effect ID is this plus plus, and then take that, take this. Then the second argument would be the effect itself, and then in the constructor it would assign the lifetime reference parameter to the effect we provide here. So it would look like this. Okay, and then I think that fixes everything up. Hopefully. Yeah, so now we have to just make the effect data constructor. Okay. Things are slowly coming together. God. What a crazy thing to try and put together, though. These are public right now, which is fine. Effect data. So we're accepting an effect ID and an effect. We'll pass it in as an R value again. And then we assign them. Effect ID to effect ID. And effect to effect. I don't know how we ended up with that macro, and now we're typing Korean. Oh my goodness. This should be... No, this shouldn't be an effect T. This should be an effect? Yes, okay. And then... finally, the lifetime gets assigned to a reference to effect dot... Okay, so this is where this doesn't work, right? Because I would have to... The template would be able to figure it out, so I could pass it in like this. But once we're outside of the template... Yeah, okay. So it would be more like... lifetime is the third parameter. So it look like this. Okay. So we should be happy now? Okay. I think so. So this should be allowed now. What is wrong with all this? Oh, there's no default constructor now. So we can't instantiate the effect data class when we initialize 1,000 members for it. So I can just add a default constructor. These can all be... Can variants be empty? That'd be cool if they were. I never really thought about that. Oh, but this is a reference, so it has to be tied to something on construction, which we can't change. You can make it a pointer. I feel like that's my only option. Yeah. Make it a pointer. Make it a pointer that we can't modify the value of, but we can modify the pointer's value. We can modify what's pointing to, but we can't modify the value itself. I think I like that, so we'll pass in the address of lifetime. Wait, no, that's... Hold on. So here, we'll pass in the address of lifetime, or we could pass it in, but it's going to come out as a reference here, which then we pass as an address here. Like, either way works. I can do it either way, but I'll pass it as a reference so that we can get the pointer to it there. I think that's okay. So now we have a default constructor, or not default, but a no default. Okay, so standard variant can't be empty, which means we could make this optional. Effect data should only exist like when we call add effect. That's the only place where we should be instantiating effect data. So if this is empty at some point, then we're gonna have a problem. So we'll do standard optional here, which will make sure that this can be instantiated correctly. And now we should be good. Hopefully IntelliSense is happy now. I was like, can variant be empty? That doesn't... I don't think that checks out. Like, what's a default value? But I think it can have a default value. Like, I'm pretty sure I've seen myself make a class of variant without an actual value. Like, I've done this before. Standard variant int comma standard string, right? And I've just left it there. Like, what does this do? Okay, it looks like it just chose to be an int. I could, yeah, just for safety. Good call. Okay, so I think, all right, so now I'm not sure what's going on. Let's see. What other errors are we at? Lifetime is not a member of optional. Oh, right, now we gotta fix this. So on effect ref, effect, what? So in here, wait, what? Hold on. What? Lifetime is not a member of optional, line 72. No member named effect. Oh, right, because now this is an optional, which we can make the dangerous assumption that it always exists. Right? Wait, what? This should have a member called... Something's wrong. Something's not, like, working right here. Effect manager has no member foreground effect list. It does, though. Wait. Initial value of reference to non-const must be an L value. Must be an L value. Oh, this is const. Wait, we can't have const, right? Because then we can't move it or copy. No, we can copy, but we can't move it now. Yeah. So that can't be const. We just can't move it. We just have to remember not to do that. What do you think about allocators? In what sense? What does that mean? Like allocating on the heap? Okay, so now this is an optional effect T, so we get the optional... Wait, what? Hold on. So this is not right. Oh, right, now we're getting the lifetime as a pointer, right? We changed that, so we have to get the value of this pointer. Or dereference it, per se. I think there's some precedence going on here. Hello? Okay, that looks old. Are they good or bad? Allocators? Well, sometimes they're helpful, but in a case like mine where we're trying to allocate a bunch of memory very quickly, like with these game effects, it's not really a good idea, because allocations can be slow and costly. Well, on the heap. But if you're just like allocating... I guess I need more context on what you mean by that. It just depends on what you need to do. Oh, should you replace the default allocator? I think I do, actually. I think I use it for like debugging, but you can if you want. New. I think I was using this for what do you call it? Memory leak testing? Yeah. At some point I did that. Yeah. It just depends what you're trying to do. It's been a long time since I used that, though. Shouldn't really be used, honestly. Like, I kind of tried to switch everything to, like, smart pointers. Is there really not much performance gained? It's more like... I wouldn't look there for performance. Does that really make sense? I would say, yeah, there's really not much to gain performance-wise. That wouldn't be the place to look. That's like when you're trying to overcome memory safety and you're just like, let me squeeze every last ounce I can, then yeah. Alright, what is going on? So, effect data, effect ID, that should exist, that should be fine. I think we're just still up here complaining. No member foreground effect list, that should be a thing, I promise, I swear. Compiler is just being, like... Or not compiler, but IntelliSense is just being really, like... slow and mean to me lately. I don't know why. Oh, there's a missing semicolon here. That's probably important. That's probably messing up everything. Yeah. That's probably messing up some things. Not a lot of things, but... Actually, I don't even know... I don't know if semicolons are even necessary there. They might be. I don't think so. Not for, like, the end of function definitions. I don't think so, because you look at my CPP file and I don't do that, so... I don't think that's the case. Alright, well, a lot of stuff is compiling, so... It seems to not be completely upset about that anymore. Now we're back to standard visit, no matching overload found. Okay, we're just going in circles now. I feel like I'm messing up, like, the headers or something. So... Should I be inlining this? I think I'm supposed to be inlining. I didn't really think about this, but I'm looking at it now and I'm like... I think we're supposed to be inlining stuff. I didn't really think about it earlier, but... Kinda? Slot ID is not a non-static data member or base class of class Effectref. Did I type that wrong? No? Wait, what's down here? Uh-oh. Am I missing a brace? Is that what's causing all this problem? I don't see one? Must be a typo here, somewhere. Like, that's matching. That's matching. Yeah, these are okay. This is starting to look like... I'm gonna split this out into a CPP file. This is starting to look like it's running into, like, header include problems. Like, I've got header include that is including this, and, like, something doesn't work now because of that. Oh. We already have one of these. Yeah, let me throw them in here. Okay, let me break out these guys. Just put everything into a source file real quick and see if that calms things down, because it looks like I've created a mess. Trying to get everything put back together. There's those two. Effectref. Alright, this particular refactor has been a lot more involved than anything we've done lately. Yeah, it would fall to the linker, so... It's probably not that, but we'll see. Okay. Let me move this guy out, and I guess this guy too. I think I got mostly everything? Yeah. Hi there, Raycasso. Welcome. Effectref. So, move those out of there. I don't think I need the consts. Oh wait, I do? Oh, dead is just not a thing anymore. Yeah. Whatever uses this probably is what I was originally looking for. Is dead. Blizzard. Not is dead, so we'll have to replace that. I guess we would know that based on the lifetime too. Like, we can actually just replace that with the substitution of lifetime is greater or less than or equal to 0. That's essentially the same thing. And I would even change it to, like, is expired or something, so I don't get confused. Okay, I think we're good now. More or less. I hope that helps a little bit. Or at least clear things up a little bit. Expected a open curly brace. At the very least, maybe this will help me figure out what is wrong. Memory leak? No. Apparently it's just an incomplete type. Incomplete type? What do you mean? Isn't this... Does this not include effect.h? Does. Why would it not? I'm just having some funny, like... Well, I can't really tell what it's complaining about right now, because I'm like, okay, the syntax is fine, so it's not that. It's like... I feel like I did something catastrophic, like, there's like something in the wrong place, and it's just messing up IntelliSense and, I guess, the compiler at this point. Just like, This is very weird. It's like, what do you mean incomplete type? How would this be an incomplete type? But let me see, because I was complaining about the standard visit thing again, but we already proved that that was okay now. So, that's confusing. Maybe it's not anymore. Maybe it's because I've changed something. Let me see. Yeah, because we've been changing a lot of stuff. So, effect. Oh, effect is now an optional, so we have to actually... Okay, so that makes sense. And then let's go back down here. Yeah, that optional kind of cascades things. This is now... Have to retrieve... Actually, we can just reference lifetime like this now. So that's okay. I think, yeah. Botox stall, thanks for the follow. Constructors don't return a type. There's no return type there? I would hope not. Or did I put a return type here by accident? No? Okay. I'm not going crazy, I promise. Everything looks okay so far. I guess I'm just gonna keep clearing these out until something makes more sense. Ordered comparison of pointer and integer 0. Ordered compare... Oh, this is a pointer. Okay, I'm glad that error's out, because that... I would have not caught that. I feel like I should... I feel like that's very unsafe. I should probably make like a... get lifetime or something, so I remember not to do that. But I'm glad it errors out there. There must be like something like that. At least maybe there was. That's kind of why I wanted to do this, because maybe it'll be easier to find, but it didn't go away. Effect.h includes effect types.h and effect types.h. Like, this is a brand new file in theory, so nothing should be including... Wait. No, that's not true actually, right? Effect types.h might include things that include effect.h? I guess that is the case. Yeah, maybe that's what's happening. I didn't think about that. Emitter? Does emitter care about effects? I don't think so. iBullets might, entities might. Something definitely might in here. Animation. iBullet. No. Well, monster might. Monster. Yeah, this is. It looks worrying. Yeah. It's probably gonna take like a day of random digging, but that's why I figured I might as well get rid of the other errors first, and then this will probably reveal itself next time. So there's that. Oh yeah, we have to do this too. So dead is true, so that no longer happens, that just ends. Yeah. Okay, well, like I said, this is probably gonna be like a 2-day thing, right? It looks like this cleared up when I got rid of that, so that is looking promising, maybe? Okay, well, it might have auto-solved itself. Like, IntelliSense has been so wild lately, but I guess if you just look at it, like, there's so much it has to interpret, so I guess that makes sense. Oh, I see. Yeah, probably just, like... IntelliSense is always all over the place now with this project. It's very hard to rely on it, and I kind of have to just go by intuition a lot of times. Just have to be like, I know this is correct, I'm gonna move on and hope... Or I just have to build every time. But yeah, I'm gonna call it here for now. It looks like we're probably like halfway through refactoring. Like there's a lot of like little things to clean up, a lot of like little behavioral changes as I figure out what I do and don't need and like what the shape of all this is supposed to be. So a little bit more and we'll probably be seeing results soon, hopefully. And then I have to write unit tests to make sure all of this actually works. So yeah, but I'm gonna call it here for today. And we'll just pick up right where we left off tomorrow. But yeah, for those of you that tune in, thanks for watching. And we'll see you all next time. Thanks for stopping by. Appreciate it. And y'all have a good one. Bye-bye.